seminar series. It is my pleasure today to introduce today's speaker, Dr. Ruveyda Komurlu. Dr. Komurlu is an architect. She graduated with all 3 degrees from a very fine school in Istanbul, Turkey. She has had 10 years of industrial experience, and then she joined academia. She is currently an assistant professor at Kocaeli University in Turkey. And she's going to talk to us about translucent concrete. Dr. Komurlu, the floor is yours.
First of all, I would like to thank you all for coming. And
Microphone.
thank you very much. Thank you all for coming, and I would like to thank Professor Arditi and Professor Snyder for giving me this opportunity. And ladies and gentlemen, I would like to talk to you about translucent concrete. It is a relatively new material called translucent concrete. Architects and engineers have been working on this for a long time, but it has been realized in the last decade. As you see, I have prepared some papers on translucent concrete, and my presentation will be based on my research. Let's talk about what is concrete. As all we know, concrete is a heavy, rough building material made from a mixture of broken stone or gravel, sand, cement, and water that can be spread or poured into molds, and that forms a stone-like mass on hardening. Although different properties may be added to concrete with admixtures and physical treatments, the most important property of concrete is its compressive strength under loads. So this is the point. And nowadays, environment and sustainability have become very important. And the use of translucent concrete in the shell of the buildings help take advantage of daylight and thus reduces energy consumption caused by lighting. Concrete is a solid material that all we know that stops light passing through. It is generally covered by decorative mortar and paint. Recently, aesthetic value of concrete has gained importance. However, letting daylight in and taking advantage of it has become important regarding the sustainable approach. This also adds an environmental value to the building. Transferring light from one point to another has been and will be a major challenge in both technological and architectural researches. One of the most interesting research topics about this is translucent concrete. Image is transferred via light rays. Eye senses the environment with the reflected light. Thus, transfer of light means transfer of vision. Translucent concrete with transferring light from one side to the other carries the vision between two sides. Various materials have been tested, and it has been found that optic fibers are the most effective of all. I will try to explain how to make the concrete translucent. Using optic fibers in concrete is actually using optic fibers for transferring light in long distances roots to late 1800s. From the early 1990s on, they have been used in industries and areas like medicine, data transfer, and communication and automotive. You can see small pieces of optic fibers, and now they are used in concrete. Let's give some small information about translucent concrete, but first optic fibers, we have to analyze it. There are three parts, three projected. As you see here, the light goes through the core, reflecting the cladding. So this is the explanation of the optic fibers and light transferring. There are three types of optic fibers. The first one is plastic fibers. The second one is silicium fibers clad with plastic, and the glass fibers. When we make a comparison, glass fibers show the best performance, and as you can imagine, it is the most expensive one. And silicium fibers clad with plastic have cost advantage but have poor performance. Plastic fibers are the cheapest optic fibers but have the worst performance of all three types. The first studies about translucent concrete have started in 1970s. The first experiments of translucent concrete have been carried out in Avon School of Architecture in early 1990s. The first samples had the feeling of enlightenment by starlight. Designers, architects, and engineers, there are so many people work on developing concrete to be used both as an architectural material and structural material. These are the most important researchers studying translucent concrete since 1999. Sorry. The first one is Bill Price. The second, Aaron Losinski, named its translucent concrete Vitracon. The third one is Andreas Bittis, works with Flora. The fourth, Halm Jürgen, he called his translucent concrete Lucon. And there is another brand, Lucem Translucent Concrete. In September 1999, Assistant Professor Bill Price from University of Houston produced the first samples of translucent concrete that had optic fibers. This is the first example that we can show you in this picture. The recognition of translucent concrete was maintained by Hungarian architect Aaron Losinski in 2002. Since then, he has been advertising it all around the world. Losinski's first application is Gate to Europe, and it was built in 2004 in Hungary. First building design with translucent concrete is Broken Church, which is not realized. This is a model, and this is another animation, but this is important for the idea of translucent concrete for the future, that these are the structural walls that they expect for the future. In Losinski's translucent concrete, he started his trials placing glass pieces of different thicknesses into a large concrete block. Then he placed optic fibers between the surfaces of concrete. There are thousands of optic fibers between the surfaces of concrete. These fibers transfer light between these surfaces, and Losinski named his brand Vitracon, light transmitting concrete. The percentage of fiber, this is really important part of this, because most of the engineers, especially civil engineers, will ask the same question, I'm sure, to me. The percentage of fibers to the total volume of the block is relatively small, just only 4%. With the help of their small size, fibers become a part of concrete. As a result of these optic fibers do not affect the compressive strength of concrete. I want to underline this. As a result of this, optic fibers do not affect the compressive strength of concrete. These concrete blocks may be used for structural purposes. The density of the concrete is 2:100 and the maximum size is 3600 millimeter to 1200 millimeter, and the thickness is 60 millimeter. In standard production, the colors are black, white, and gray, but if you demand another options, they can produce in various size and colors. The percentage of the fibers to the total, since the fibers transfer light up to 20 meter without loss, theoretically building a ball with the thickness of 2 meter is possible. Concrete blocks have the same effect for natural and artificial light sources. Another translucent concrete is Andras Bittis translucent concrete. Bittis founded the company with Aaron Lazansky in 2004, but then he left the company and he began to produce his own translucent concrete. He used textures that weren't covered by Aaron Lazansky and John Richardson's patents. Briefly, Lazansky uses fibers, Richardson uses bundles, and Bittis uses textures of optic fibers. Since the uses of textures of optic fibers, Bittis's translucent concrete has a clear structural line. The maximum dimensions are 2000 millimeter to 1200 millimeter, and the dimension thickness is 2 centimeter. The thickness for fibers vary from 2 meters to 2 millimeter. The compressive strength is 70 Newton per square millimeter. The colors are similar to Lazansky's, white, black, and gray. Another translucent concrete is Halm Jürgens translucent concrete. He started producing his own version of translucent concrete in 2006. He states that he has found a semi-automatic process to place light transmitting material into concrete. He points out that with this semi-automatic process, he can produce large amounts of translucent concrete in short periods. The block has different layers of optic fiber textures with various light transmitting coefficients. This texture is made of high-quality optic fibers, and the diameter of fibers, the distance between them, and the surface texture is precisely calculated. Jürgens translucent concrete blocks may be produced in dimensions of 90 cm to 30 cm and thicknesses of 25 mm to 100 mm. So you can see the thickness goes up. Both surfaces are covered with a protective layer. Let's talk about the examples of the all translucent concretes. Now I'll show you the application examples. The first one is from the main entrance door of museum, and this is the final of the example. And the second one is 2007 in Belgium Cement Association Fair. And as you can see this picture, in the early stage, size of blocks were small. In order to obtain big surfaces, steel grids and frames were used. You can see these grids and frames. Another example from the front desk of the Corvinus University in Budapest, and the Square Sanders Council Budapest again, and you can see the design of the concrete. You can give some textures, some designs in concrete. This is an open-air monument which is in New Orleans, Iberville Veterans Memorial. So you can see the translucent concrete in this monument. And actually Actually, they use translucent concrete in some houses. The house in Budapest, 2010, you can see with light and without light. This is another example. This is a logo which is in the facade of the building and with the light at the back. In this example, it is really important because they use the panels in monument. These panels are much more bigger than the blocks. One of these panel is 2 meters and 50 centimeters in Ida Popsula statue. Another brand is Lukon. You can see some pictures from the mall entrance in Seoul. The wall examples from the jewelry shop front, again from the Lukon brand. And this is another example because normally we use blocks or the regular translucent concrete, but you can see some wave panels. You can give extra shape of it. And this is Luca Master Showroom. You can see the most famous picture of Andy Warhol. It was made translucent concrete. Another example from Lusam. This is again front desk in Arup's office. You can see these details of translucent concrete and these optic fibers. They are all optic fibers, thousands of optic fibers. Another example from Bank of Georgia. This is again Lusam brand, and you can see a meeting room, and this is the inside of the meeting room. This is again Bank of Georgia, and how we can produce the translucent concrete. This is the important part, I'm sure. Lusam cement mixing. You can see the optical fibers and pouring in the concrete, cutting and polishing. There is another detail from the floor tiling detail in application of concrete. There are some ideas for the feature, and you can see the helipad at the top of the building. And the ideas of feature, structural wall. They want to make structural wall with translucent concrete. As you remember, at the beginning part of my presentation, there is a design of building for the church that they want to make translucent concrete of its structural wall. And another example for the ideas of the feature, shell of a building. So you can see these all shell of the building can be made in the future with translucent concrete. And thank you very much for listening to me. And excuse me, I want to please, this is a really important part. I want to show you the examples of the translucent concrete. I have a rabbit in my head. So, this is one of the examples. But first of all, I would like to starting my presentation. These samples were made in his class last semester, and now we can see the image of it. Yes, thank you, Mr. Klashen. This is small pieces of translucent concrete, but you can see all optic fibers in it. It is really useful to understand this material. So you can see the vision at the back of this material. And this is a big part of it. Can you see?
No, you have to hold it follow the line.
Oh, yeah. Very nice. You can see the vision at the back of the concrete. It is like a regular concrete, also heavy. It is also strength. So there are optic fibers are in this sample. Thank you for these samples.
I would like to forward the thank you to the students. Two of them are here, Jen and Paul, sitting there. They are part of the group that produced.
Thank you very much.